Okay, good morning. We are going to be working with prisms and cylinders today and finding the surface area of those. So I'm just going to hop right down into the lesson here and let's define a prism. So a prism is a polygon with two congruent faces called bases that lie in parallel planes. So if you'll see in this picture, there's a hexagon on the top in the bottom, so those are your parallel planes, so those are your two bases, and then all the other faces that go around are called our lateral faces. Okay, so right here it says the other faces called lateral faces are parallelograms formed by connecting the corresponding vertices of each base. The segments connecting these vertices are called lateral faces. Sorry, lateral edges, my bad. All right, so the surface area is the sum of all the areas of its faces. So if you think about this picture up here, we have a hexagon on top, we have a hexagon on bottom, so that's 2, and then you have 6 of these parallelograms going around connecting. So that would be a total of 8 faces, okay? The lateral area, if they ask you for lateral area, that's going to be the sum of the area of its lateral faces. So you might want to put in parentheses here, no bases included. So it says find the surface area of a rectangular prism with a height of 3, a length of 6, and a width of 8. So your height is typically that distance that connects base to base. And really with a rectangular prism, any of these technically could be the bases. I'm going to take the bases as the top and the bottom. So this is my height, 3 centimeters, that's connecting the top to the bottom. And then I'm going to do length of 6 and width of 8. And you could have put those the other place. It doesn't really matter. Okay. So we're not going to do all these like this. I'm just going to kind of go through this one and show you. So I'm going to call it top and bottom, and then I'm going to call it left and right side, and then we'll do a front and back. Okay, so we've got obviously two faces, the top and the bottom, that are 6 by 8s. Okay, then the left and the right side is an 8 by 3, so we got 2 of those, an 8 by 3. And then the front and the back, so that would be like this piece up here on the front. So this would be 3, right? Because that's the same as that. And then this would be, the way I labeled it, would be our 6. So this is a 3 by 6. And you take all these numbers. So this is going to be 96. This is going to be 48. And this is going to be 36. Okay. And that's all the different lateral faces. And then you just add those up. And I think this ends up being 180. Does that sound right? Centimeters squared. So this is 20. So 2, 11, 15, yeah, 180 centimeters squared is the surface area of that rectangular prism. Okay, so in general, surface area is the area of all of the faces of a 3-dimensional figure, all of them added together. Okay, now we are going to kind of look at a generic formula to help you through these. And so that's what I'm going to talk about right now. So it says theorem 12.2, the surface area of a prism is going to be 2 big B plus LA. And I want to make sure you know what these represent. So big, capital B, is the area of the base, and LA is all your lateral faces, okay? We also name every single prism, pyramid, by its base, okay? So what are there 2 of? So name by base, and you're asking yourself, what are there 2 of? So in this one, we have, this is called a triangular prism because it's got the triangle on the top, triangle on the bottom. Now, obviously, since a triangle has 3 sides, it would have 3 lateral faces going around it. Okay, so what we do In this instance, and I'll kind of show you up here, and that looks like we're going to deal with one of these right here. We write the formula, the generic, this is the generic formula, and then I realize it's a triangular prism. I would probably put the name up above the generic formula. So what's the formula for area of a triangle? It's 1/2 base times height. That goes in for big B. And then these are just 3 rectangles that are connecting. Now, here's the catch. That's really interesting on this lateral area part. You could have 3 of the same exact rectangle if this was equilateral, okay? But if it was isosceles, you would have 2 of one rectangle plus 1 of a different sized rectangle. And if this triangle happened to be scalene, you would have 3 different rectangles here. So that's where it can get a little tricky, okay? So let's look at our first example. This is also a triangular prism. It's just that the bases are kind of facing us here. So I'm going to write down 2 big B plus LA. So 2 times 1/2 base times height plus, now I got to think hard about my lateral area, okay? This is 6. This we don't know, but if you look back here, we do know it. It's also 6. And then this is also 6 right here. So this is an equilateral triangle. Because of that, I know I have 3 congruent rectangles as my lateral area. Okay, so I'm going in here. What's the base of my base? Base of my triangle is 6. Now, it wants the height, which would be this. It wants that height of that triangle. A couple ways you could go about this. I'm just going to do good old Pythagorean theorem because I know that's 3 and I know that's 6. So I'm going to say 6 squared is h squared plus 3 squared. So 36 is h squared plus 9. So we subtract the 9, sorry, from both sides. So we got 27 is h squared, and then we're going to square root that. I don't know that I have a calculator on me right this second, so this is going to be 3 root 3. You obviously can take that to a decimal, and that's fine. Sorry. All right. Then I have 3 rectangles that are all 6 by 8. So this is a 6 by 8 on the right, 6 by 8 on the other side, and 6 by 8 on the bottom. So that goes there. All right. So those 2 times 1/2 actually crosses out. So this ends up being 18 root 3 or whatever decimal you have, plus 3 times 48 is 144. And when you add all that together, you should get about 175.2 inches squared. Remember, this is area, so all of our units should be squared. Okay, so obviously a cylinder, it still has 2 bases, but it brings in this circular aspect. So we will, it still starts off as 2 big B plus LA, okay? But this formula becomes, so what's the base of a cylinder? Well, it's pi r squared, so 2 pi r squared, plus this becomes 2 pi r h. Mainly because, and if I was in class right now, I would totally do this for you, but if we unrolled, if you cut this cylinder and unrolled it, it would be a rectangle. And the distance all the way around this thing is 2 pi r, that's circumference, and then height is up and down. That's where that 2 pi r h comes from. Just to kind of, hopefully that'll make you stick in your brain a little better, but 2 pi r squared plus 2 pi r h also kind of flows, so that's your formula for a cylinder. So here we go. Find the surface area of the right cylinder shown. So I'm going to say this is a cylinder. Surface area is 2 pi r squared plus 2 pi r h. So my surface area is 2 pi times 4 squared plus 2 pi times 4 times 5. Now, a lot of times people like to leave these in terms of pi, which I'm not against at all. It's really kind of up to you. And I think on like a standardized test, you might see it both ways. So you could say this is 72 pi, let's see, meters squared, which is, I think, about 226.1 meters squared. You'd have to obviously punch that in a calculator. I will take either answer, okay? So whatever you prefer. Okay, find the height of a right cylinder. The radius, so we got a cylinder, radius is 2.8, and they tell us the surface area. So we know it's a cylinder. Surface area is 2 pi r squared plus 2 pi r h. This one's a little different because we know this is 198.8, and they tell us the radius is 2.8, and they want us to find the height. So there's definitely going to be some algebra involved here. Okay. So this is 198.8 equals, so in your calculator, you would want to do 2.8 squared times 2 pi. I have on my page 49.2352, so hopefully that's close to what you're getting. And then 2 times pi times 2.8 is about 17.584 h. Now just remember, you're trying to solve this to get h by itself. So first I'm going to subtract 49.2352 from both sides. And that gives me, do I have that number on here? Yep, I do. 149.5648 equals 17.584 h. When you divide both sides by 7.584, you're going to give it h to be about 8.5 millimeters. Okay, and then our last one for this section of notes says find the surface area of a right pentagonal prism. So pentagonal is going to be important where the bases are regular polygons. That's important for us. Round your answer to the nearest hundred. So it's a pentagonal, meaning 5 sides. Prism, surface area is 2b plus LA. So the area of my base of a regular pentagon is 1/2 apothem times perimeter. Plus, because that pentagon base is regular, I'll have 5 of the same rectangles going around as the lateral faces. Okay, so let's kind of look at what they've given us. So it looks like we do not have the apothem. I'm going to kind of space this out a little bit. So we need the apothem. Now the perimeter, it looks like they gave us a side length of 7.05. So my perimeter is going to be 5 times 7.05. And I don't know if I come back to that in just a minute. Okay, and then you also have to find your apothem. So within this triangle, we have a radius, and technically you have this side if you wanted to cut it in half. We're kind of used to going, okay, 360 divided by 5. And that's going to be 72 degrees, but then you cut it in half. So we get this to be 36, and this is 6, and we're trying to find apothem. Okay, so obviously, like I said, you could cut that 7.05 in half, and I think that would be 3.525 here. And you could use Pythagorean theorem, or you can use SOHCAHTOA, whatever kind of floats your boat here. I would probably have just maybe used cosine of 36 is a over 6. Some people might have used sine here, or even tangent. I mean, especially if you have all the numbers, okay? So I got A to be about 4.85. So that goes there. That's my apothem. And I think if you use Pythagorean theorem, it might be like slightly different, which is not a big deal at all. Okay. And then we have back here, you have to look at this rectangle right here. So what is that rectangle? Well, it's a 9 by whatever the side is. So 9 by 7.05. And then I need to put my perimeter in there. 5 times 7.05. 5 times 7.05 is 35.25. Goes here. I finally have a calculator over here. The 2 and the 1/2 you really could just cross out. So I'm doing 35.25 times 4.85, and that's 170.9625 plus 5 times 9 times 7.05, which is 317.25, and then add those together. And I'm getting about 488.2 feet squared. Just be careful in your homework. Make sure if it's asking you for lateral area that you are finding just the area of the lateral faces, and do not include the bases if they do that.